Hi guys, it's Miss Brown, and I just wanted to take a second to explain the notes from yesterday to you. I gave you the filled out notes, but I really believe that I need to say more about them. So here we go. A proportional relationship. We have been working with proportional relationships, even though maybe you don't know it. All a proportional relationship is just a set of equivalent ratios. Okay, and please remember that ratios are just fractions. So don't let the terminology confuse you. And here's what I mean by equivalent. Okay, so I'm going to write on the right hand side of the screen, but I'm going to erase it. Um, what if I gave you the ratio 3/4? Okay, so 3/4, what would that look like? That literally is 3/4, right? So I'm going to draw what I'm going to call a cake, or it doesn't matter, a rectangle. And I'm going to divide that rectangle into four equal sections. And then I'm going to color each section. So 3/4 sections I will color. So that's one section, that's two sections, that's three sections, right? So I need you to notice something. What would happen if I multiplied 3 times 2 and 4 times 2? That would give me the equivalent fraction of 6/8. And I can also use my picture to demonstrate that 6/8 is an equivalent fraction. So what I'm going to do, notice I still have the same amount shaded purple. I'm going to take my existing picture and I'm going to divide that in half. Now, if you notice, after dividing it in half, I have one, two, three, four, five, 6 sections shaded out of 8 sections total. What I need you to see is that 3/4 is equivalent to 6/8. So hopefully, in your mathematical studies, hopefully you have talked about equivalent fractions. If you haven't talked about equivalent fractions, all a proportional relationship is just a set of equivalent fractions. All right, so let me choose another color, and I'm going to look at 3/4, and this time I'm going to multiply it by 3. So I'm going to multiply the numerator, 3 by 3, and I'm going to multiply the denominator, 4 by 3. 3 times 3 is 9, and 4 times 3 is 12. So 3/4 and 9/12 are equivalent. And I want to prove that to you with a drawing. So I'm going to draw another rectangle, and I'm going to try to divide my rectangle into 12 equal sections. Well, first I'm going to divide it into 4 sections, okay? So here are my 4 equal sections. And then I'm going to color 3 out of the 4 sections. So here's 1 section, 2 sections, and 3 sections, okay? So with my model, I have just represented the fraction 3/4. Now I'm going to take my model and I'm going to divide it into 12 equal sections. So if you count, I have now divided it into 12 sections. Well, notice I did not change the part that I painted green. It's still the same. It's just divided up a little bit differently. But see how we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sections out of 12 shaded. So therefore, 3/4 is equivalent to 9/12. So when I talk to you about proportional relationships, all I'm talking about is a bunch of equivalent fractions, like 3/4 and 6/8 and 9/12. Okay? Now let me show you one more thing. I'm going to get my calculator here, and I want you to see something. I'm going to take that 3 and divide it by 4 and press enter. Notice that 3 divided by 4 is 0.75. So I'm going to return here and just note that if I do that division, 3 divided by 4, I get 0.75. Now, I'm going to go back to my calculator, and this time I'm going to take 6 and divide it by 8. So I have 6 divided by 8 equals, notice that's also 0.75. So I'm just going to make a note for future reference that 6 divided by 8 is equal to 0.75. And then last off, I'm going to take 9 and divide it by 12. So I'm going to go to my calculator and press 9 divided by 12 equals, and that is still 0.75. So I'm going to return here and just make the note for myself that 9 divided by 12 is equal to 0.75. What I need you to see here, guys, is that even though we have fractions that look different, 3/4, 6/8, 9/12, they look different. But when we do the division and simplify these fractions to the same unit rate, we get the same number, 0.75 every time. So if you have a proportional relationship, all your fractions will simplify to the same unit rate. Moving on, let's talk about a proportional table. So all a table is just a method to organize and display equivalent ratios. All right, so let's talk about displaying this table. There are different ways to display a table. You can make a horizontal table, and that's what I'm going to attempt to make in the corner down here. And in this particular table, I'm actually going to put my Y values on the top. I'm going to put my X values on the bottom. Sometimes, guys, people reverse this order, so you have to be careful here. The X, sometimes we call the input. In science, the X is called the independent variable. And then the Y is called the output. And in science, the Y is called the dependent variable. So watch what I do with these fractions, okay? So I have the fraction 3/4, right? All I'm doing is putting that fraction in the table, 3/4. And then my next fraction is 6/8, 6/8. And then the last fraction is 9/12, 9/12. Guys, also be aware that that table can also be in vertical form. So let me write that vertically. But here's the thing with vertical tables. Generally, this is not a hard, fast rule, but generally the X's are in the left-hand column and the Y's are in the right-hand column. So you kind of have to be careful. It really depends on who's writing your table. And so if I look, my X down here is 4. and the y that corresponds is 3. My x is 8. The y that corresponds is 6. My x is 12. The y that corresponds is 9. Okay, so that's the same table, just written in a little bit of a different format. All right, the next thing I would like to talk about. I need you to know that when we have these fractions, okay, the denominator, remember, denominator is the number on the bottom. The denominator of the ratio is the x coordinate, and that's also what we call independent variable in science. Okay, and the numerator of the ratio is the y coordinate. All right, moving on. The next thing we're going to talk about is constant of proportionality. Now, guys, I'm just going to be straight up honest with you. This whole constant of proportionality will not make 100% sense right now. But give me a few days, and hopefully it will help. Hopefully we'll understand more. Anyway, moving on. I need us to know that constant of proportionality is just the unit rate, guys. All it is the unit rate. Also, we can think of the constant of proportionality as the multiplier. Okay, so going back, remember we had a y of 3 and an x of 4, and I just pulled that value out of the table. And we said that when we simplify that, or when we do the division and get the unit rate, we get a 0.75. Okay, so here our constant, which we represent with the letter K, not C, but K, is equal to 0.75. And remember, I told you that it is a multiplier. Well, here's what that 0.75 is telling us. It's telling us in our table, if I take my x values and I multiply my x values by 0.75, I'll get the y value. For instance, 4 times 0.75 equals 3. 8 times 0.75 equals 6. 12 times 0.75 equals 9. All right. And then we'll be writing an equation form of our proportional relationships. For the equation form, the only thing that we have to do is plug in the value of the constant. And we've already said that the constant is equal to 0.75. So if I ask you for the equation form, the correct answer would be y is equal to 0.75. And remember, the constant of proportionality is just the unit rate. And guys, I know right now this all doesn't make sense. It's okay. Right now, we're just taking notes. And by the way, for my online students, I have not told you to keep a notebook, but I strongly encourage you to either have a notebook where you keep notes for math, or if you are already doing that in a binder, that's a great idea as well. Anyway, let's go over here to proportional graph. I need you to know that a proportional graph looks like the following. A proportional graph will be a straight line. It'll be a line passing through the origin. And in case you don't know what the origin is, the origin on a coordinate plane graph is the point 0, 0. That point 0, 0 has a special name, and the name is the origin. So I want us to look down at our notes, and let's talk about examples and non-examples of proportional relationships. So the top row that you see on my screen, are all the same example, first of all, and they all show examples of proportional relationships. And I'm going to go and mark this out because information is incorrect. So anyway, in the words, we have 2 candy bars cost $3, right? So I can go in my table and just write. Notice I have the quantity of candy bars on the left, costs in dollars on the right. So I already know that 2 candy bars cost $3. Well, how much would 4 candy bars cost? $6. How about 6 candy bars? $9. What if I ask you for the unit rate? And if you remember the definition of unit rate, a unit rate is just a ratio with a denominator of 1. So basically, I'm asking you, how much does 1 candy bar cost? And hopefully you've already figured out that it's $1.50 per candy bar. Okay, that is the unit rate. Let me tell you what that $1.50 is telling us. That unit rate. Remember, unit rate is also what we call the constant of proportionality. All that is telling us is that if I take the values on the left-hand side in the X column, I take those values and multiply those values by 1.5, that'll give us the values on the right-hand side. So, for instance, 6 times 1.5, I'm actually going to write this kind of backwards, but anyway, 6 times 1.5 equals 9. And I know I'm writing backwards, just bear with me. And 4 times 1.5 equals 6. And 3 times 1.5, uh-oh, that's wrong. Sorry about that. 2 times 1.5 equals 3. So to write the equation, all we do is we fill in the value of k. Remember, the generic form is y equals kx. So if I ask you to write the equation, the correct answer would be y equals 1.5x. Okay? Now, let's put those points in our table on a graph. So we know 2 candy bars cost $3, and we know 4 candy bars cost $6, and we know 6 candy bars cost $9. And I'm just going to go ahead and add the rest of the dots following that pattern. And honestly, I can get out a straight edge or ruler and connect those dots. And I want you to examine our graph. Our graph is a line, and our graph passes through the origin. And remember, the origin is the point 0, 0. I'm going to put a star down here at the origin just so we're clear that the origin is this point right here. Okay? Now, let's look at let's look at an example or non-example of a proportional graph. Sorry guys, got tongue-tied there. Anyway, it says to rent a bike, there is a $10 rental fee plus a charge of $2 per hour. Now, I want you to think about this. If I go to purchase a bike just for 1 hour, right? I'm going to have to pay that $10 plus I'm going to have to pay that $2 for that hour, right? I only have 1 hour, so 2 times 1 is 2. So for 1 hour, I'm going to end up paying $12. Let's think about for 2 hours. Okay, I'm still going to have to pay that $10 rental fee, but I'm also going to have to pay $2 an hour for 2 hours. 2 times 2 is 4, plus 10 is 14. So for 2 hours, I'm going to end up paying $14. Let's look at 3 hours. So I still have to pay that $10 rental fee, and I'm still paying $2 an hour, but this time I'm renting my bike for 3 hours. So 2 times 3 is 6, plus that $10 is 16. Guys, the equation for the relationship that I have just talked about is y equals 2x plus 10. All right, and let's put those points on a graph. So we know we're going over 1 hour, and that's going to cost us $12. We're going over 2 hours, and that's going to cost us $14. We're going over 3 hours, and that's going to cost us $16. And I'm just going to continue the pattern. Now I want you to look at this graph. Notice, yes, this is a line, but this graph does not pass through the origin. And for that reason, it doesn't pass through the origin. This graph is not proportional. All right, guys, hope this helps. Thank you. Bye-bye.